All right, have your homework out, if you would please. Books open to page 63. We just reviewed over those fraction decimal equivalents, drilled them together as a class. We played some around the world. Michael crushed it. We had some good performances by Luciana, and Griffin also made it several seats. But Michael, the undisputed winner. And so we'll see, maybe tomorrow we can get someone to dethrone him.
I will.
And his poor eyesight. All right, so anyway, but we'll work more on that tomorrow. Make sure you're working to memorize those. Students in here, make sure you make some flashcards and drill a little bit. No one apparently did that last night, but you're going to eventually run out of time to do that. So I would suggest tonight making those flashcards and drilling to make sure you've got them memorized. For now, we're going to look at the homework, page 63 to 64. You did some review work, numbers 35 to 52. And on number 35, it said last year Philip saved $513 per month. How much did Philip save last year, Bryson?
$6,156.
There we go, $6,156 is correct. We just multiply by 12 because there's 12 months in a year. Number 36, Jack drove 396 miles. Jane drove 521 miles. How many more miles did Jane drive than Jack? What did you have for this one, Paige?
125.
125 miles is correct. Number 37, when we multiply by 1,000, what do we get? Kirsten?
0.00754.
Uh-oh, remember, Mr. Driver's license, and we're multiplying, so we go to the right with the decimal 3 times. So we should have gotten what here, Corey?
7,540.
7,540 as opposed to going left there. How about number 38? Just curious. Let's go for redemption here, Kirsten. What'd you get on that one?
0.023.
0.023 is correct. How about number 39, Elaine?
3,400.
3,400. And number 40, what did you get, Jalen?
I got 0.334250.
Good. Well, you don't necessarily have to have the 0 at the end, but it's not a problem. 0.33425 with or without an extra 0 at the end. Number 41, order of operations. Been a little while since we've done these. What did you get for your answer, Griffin?
19.
19 is correct. Number 42, what did you get, Ben?
5.
5 is correct. Number 43, what did you have, Michael? 6. Number 44, Corey?
36.
36. Number 45, Sam?
53.
No, Luciana?
45.
45 should have been our answer there. We can take a look at these in a minute. How about number 46? Let's go back to Sam for redemption. 11 is correct. Turn the page. Number 47 through 49, you were finding the greatest common factor. Remember, the key is to prime factor the numbers and see what they share. What do they share? You might want to write the word share next to this section. And what do 12 and 28 share, Bryson? 4. Go put the water bottle on the floor. Ditto. Number 48. What do 45 and 54 share? Jalen?
9.
9. Number 49. What do 42 and 63 share? Elaine?
7.
They share more than that. Luciana?
21.
21. If you didn't prime factor, though, you probably wouldn't think of the 21. But if you did prime factor, they both have a 3, they both have a 7. There's your 21. For number 50 through 52, we're finding least common multiple. For this class, we are looking for winners. Write the word winners next to this little section. And when you take all the winners of the prime factoring, it'll give you your LCM. So for 45 and 90 for redemption, what's the LCM? Elaine?
90.
90. Number 51, 24 and 56. We really probably needed to do the prime factoring here. What do we get, Griffin?
168.
168. Great job. And for 44 and 66, what's that LCM on number 52 page?
132.
Great job. 132. I am curious. Was anybody perfect on the homework? Now, this is all review. Wow, several. Anyone just missed 1 or 2? Just missed 1 or 2 problems. All right, let's take questions now. Michael?
Would it be okay, or if we just saw, like, for number 50, if we saw 45 and 90 and we knew 45 times 2 right off the back is 90?
Yeah. So, like I say, but you're taking a gamble if you don't prime factor. For instance, Elaine, I think, took a gamble on 49. It didn't prime factor, am I right? You did what I probably, in my pride, would have done and been like, I already know they're on my 7 times tables. I know it's 7. I don't need to prime factor this. And sometimes we get burned, right? But no, I mean, it's your chance you're taking. I would say on quizzes or tests, take the time to prime factor. But homework, if you want to take a gamble, just sometimes we lose on our gambles. Question, Jalen.
So with the LCM,
Yes.
I list out the multiples instead of prime factor.
It just potentially takes longer, especially with harder numbers like 56, like trying to list. Of course, in that case, you only had to go, 3 multiples into it. But still, sometimes it can take a while to do that. The prime factoring is going to be the most efficient way in most cases. But it's not a wrong way. I mean, that's what I used to show it in the first place. So it's not necessarily wrong. It's just not always efficient.
It's honestly more comfortable for me to do
For
it
you?
that way.
That's fine. All right. Any other questions? Sam, you had missed one of those. It was number 45. Did you already find your mistake, or do we need to take a look at it? Yeah, let's take a look at it real quick. We've got a 105 divided by 5 plus 8 times the quantity 6 minus 3. What do we need to do first here, Sam? Parentheses, which gives us a 3. All right, once parentheses are done, my next step is usually to take care of any, well, normally it would be exponents. I just don't have any. So for this problem, my next step is to do my division and multiplication. So 105 divided by 5, anybody? 21, good Sam. And to Kaduka himself, and then 8 times 3, 24. And then when we add those together, that's where we get 45 for our answer. Does that make sense? All right, good. Any other questions on the homework? Any other questions on the homework? All right, flip back just a page or so to page 61. Flip back to page 61. I want you to do the review, 19 to 29. Page 61, the review, 19 to 29. Some of the fraction decimals are memorized, or hopefully memorized. What if you don't have it memorized, or what if it's not one that we're supposed to memorize? Class, how do we turn a fraction to a decimal? Divide. Which one goes in the house?
Numerator.
The top number goes in the house. The top dog, right? He's in the house, and then the guy on the bottom, he has to stand guard outside. Doing numbers 19 to 29. Gonna have to get creative on some greater than, less than, equal to things, right? See if you can figure that out. We'll take a look at it in just about another minute and a half. Keep working for about a minute and a half. We'll take a look at them together. people already finished. Michael's done, Corey's done, Ben finished, Paige finished? Yes, no? Keep working. Luciana finished? No. All right, pencils down. Even if you're not finished with all of them yet, let's take a look at these. 7/8 class should be memorized.
0.875.
0.875. If not, let's get it memorized. 4/9 should be memorized, class.
0.4
Because
repeating.
anything over 9 is itself repeating except, right, we said 1/9 is what, class? And we said like 5/9 would be,
0.5.
what about 8/9? What about 9/9?
0.1. I mean 1.
1. Not 0.9 repeating. 1. Is there such a thing then as 0.9 repeating? That would have to be 9/9, but it's not, it's 1. So have you ever heard somebody say, well, there's like a 99.9 repeating percent? There's no such thing as 0.9 repeating. You can do a whole lot of 0.99999s, but if you actually have it repeating, technically that's impossible. Anyway, thought I'd mention that. 5/16, we didn't memorize that, did we? So here, class, we're going to have to do our division. What goes in the house? 5. What goes outside the house? 16. Make sure we get it right. The top number goes in the house. Don't forget your decimal with some zeros. Don't forget to also put the decimal up top. How many 16s would fit into a 50? 3 of them, right? 3 times 16 comes to a 48, so when we subtract, we get 2. Bring down a 0, 16 goes into 21. 1, so with how many left over?
4.
How many times would 16 go into 40?
2.
Just twice, because that's 32, leaves with how many? 8. We're not done yet, let's add another 0, bring it down. How many times would 16 go into 80?
5 times.
5 times, and it actually works out evenly there, so it's a 4-digit decimal. How many got the 0.3125? You worked it out. Excellent. Questions on that? 5/8 we should have memorized, class.
0.65.
0.65. 1/6 should be memorized.
0.168.
Or we're memorizing, right? Memorizing if we don't have them already memorized. Looking at number 24, we had to get a little creative here. It says, which is greater, 0.8 or 8/9? Well, class, what is the decimal for 8/9?
0.8 repeating.
0.8 repeating. Is 0.8 repeating bigger or smaller or equal to 0.8? It's bigger, because this is 0.8, and what would be the next digit if I wrote it, class? A 0. But here if I wrote the next digit, it'd be another 8, right? Which is bigger than this, so how many had less than for number 24? Less than. For the next one, we had 22/25 versus 3/4. How do we compare these? There's 2 ways we could do it. One way would be to get a common denominator. You could multiply top and bottom by 4 here, class, to get
188.
88 over 100. Here you could multiply top and bottom by 25. Think money. What's 3/4?
75.
75 cents. So 75 over 100. So which one's bigger, class?
88.
The first one, the 8800. So therefore, greater than. How many figured out a greater than? The other alternative was to go with a decimal. This is 0.75. This is, if you went with a decimal, 0.88. 0.88 is greater, so therefore 22/25 is greater. Either way would work there. Number 26, I think this is probably best to go with the common denominator, because 16 makes a great denominator. 1/2 is how many 16ths, class?
8. No.
1/2 becomes 8/16, doesn't it? Top and bottom by 8, which is bigger? 9/16. How many had less than in the blank for number 26? If you aren't getting these, does it make sense how to do it now that you've seen it? Common denominators or changing to decimals? Question.
Can't you just look at the numbers? Because
Can you?
yeah, because if you put 8/16 down, if it was like 8/16, if 9/6 was 8/16, it would be 1/2, but 9/6 isn't.
That's what we just did.
Oh.
Look at the next one. 4/5 or 7/9? Well, you know a great way to compare these? What's 4/5 as 7/9? What's 4/5 as a decimal, class? Point eight. What's 7/9 is a decimal?
0.7.
repeating.
Which one's bigger?
7 repeating.
Oh, no, because this is
Okay.
0.80, this is 0.77. Now, granted, it keeps going, but because the first digit is bigger, this one's automatically bigger. 4/5 is going to be bigger than the 7/9, having a greater than for number 27. You could have also gotten a common denominator. Look at the next one. They said 4/16 or 0.25. Well, what would this reduce to, class? 1/4. And what is 1/4 as a decimal? 0.25. So, class? Equal to. How many figured out they were equal to each other on 28? Number 29, they gave you the decimal point 003 versus 300ths. Here I would think place value. What is the place value of the 3 right here, class? Thousands. This is 3 thousandths. This is 300ths. Which one's bigger? The 300ths is bigger, right? Would you rather have to divvy up I don't know, what would be something you would even divvy into 1,000 parts? I don't even know. Maybe, I don't know, an inheritance or something among, I don't even know, whatever. Would you rather 3,000ths or 300ths, right? You'd rather have 3 parts out of 100 versus 3 parts out of 1,000, or you could have gone with the decimal, 0.03, right? They match, this one's bigger, that one's bigger. So how many have less than for number 29? All right, questions on the greater than, less than. Just, again, you could use fraction decimal, you could use decimal fraction, you could go common denominators, whatever. There's different ways to show the comparisons there. Flip back to page 57, if you would, please, now. Back to page 57, and we'll kind of use this idea of division with a fraction bar. Talk about something called unit pricing. How many of you have been shopping with mom or dad? Usually mom, let's be honest. Dad just like goes and buys whatever. Well, not all dads. I mean, some dads think critically. I usually do. But you go in there and they look for the best value on items. They're looking for the better value, which sometimes is hard. Like, I mean, if 2 jars of peanut butter are the same size, the cheap one is the better value. Now, you might not like the taste, right? And they say that choosy moms choose Jif. You haven't heard that? Choosy moms choose Jif? How many have Jif peanut butter in your house? Okay, anyway, only a couple of you have choosy moms. Anyway, but anyway, I like Jif. But anyway, that's mainly because that's what I grew up on. How many Skippy people do we have here? Any Skippy people?
Yeah.
All right, how about Peter Pan? Got some Peter Pan people in here. Let's see, what other brands are out there? Reese's actually makes peanut butter in the jar. All right, it's okay. Let's see, what others? Great Value. Great Value. Really going for the. I've had it. It's just, I don't know. I don't feel it tastes as good. Sorry. Now, none of these products have opted to endorse my YouTube channel. So if I could be persuaded to go Skippy if Skippy were to never mind. All right. So anyway. That's free. Anyway, but unit pricing, right? Unit pricing is basically determining the cost of an item divided by its total size and figuring out the cost per ounce, cost per pint, cost per gallon, cost per whatever, right? Does that make sense? So look at the example problem that they have here just above the blue shaded box. Just above the example 1.11b, it says if a 16-ounce can of tomatoes costs $1.25, the unit price is the cost, $1.25, divided by the number of units. Well, there's 16 ounces, so they would divide by 16. And they did all the math and all that stuff with the calculator, and they got about about 8 cents per ounce. Do you see what they did? Look at the example problem now. Olive oil. How many of your parents cook with olive oil? How many cook with canola oil? How many have no clue what oil your parents cook with? Yeah, okay. So anyway, olive oil is a little more expensive than the other oils, but it's more healthy for you. It's better for you. And so you could buy and this is actually really close to accurate. I Googled it last night because I was curious. A 17-ounce bottle of olive oil, not Walmart brand, but name brand, does cost about $7.56. So what do we need to do to find the unit price? Well, you take the cost divided by the number of units. What's the cost of the olive oil bottle, class? And how many units? How many ounces, class? 17. So we're going to divide the top number divided by the bottom number. Don't lose your decimal. How many 17s do you think we could fit into a 75?
2.
This is not quite 20, right? And this is not quite 80, right? So 2 would go into 8 about 4 times. Let's try 4. 4 times 7. 28. Let's try carry it to 4 times 1 plus 2.
6.
Oh, that works. How many do we have left?
7.
7. Let's bring down a 6. Well, how many times is 17 going to go into 76?
4.
As many times as it went into 75, right? 4 again, which means it's going to be another 68, which we can subtract and to do a little borrowing to get 8. Let's add a 0. How many times is it going to go into 80?
5, yeah.
No, same thing again, still 68. 4 again. So this is going to be about 44 cents per ounce, right? And that's what they've got there. They got about 44 cents an ounce. That's the unit price for the olive oil. But you notice, right? You know when you go to the store, they have the little jar of peanut butter, the big jar of peanut butter, like the mega jar of peanut butter. You're like, yeah, that'd go bad before we finished it. Well, what if you cook with a lot of olive oil? Maybe do a whole lot of, cooking with olive. I don't know, maybe you just really like olive oil. And so they do make bigger bottles of olive oil. So I looked this up, and you could actually get a 51-ounce bottle of olive oil. That's a really, really big bottle of olive oil. And you can get it for about $19.89. Now, depending on where you live in the country, inflation hits different rates in different markets. But around here, that's about the price for a 51-ounce bottle of olive oil. So, let's see, what would be the unit price here? Well, in order to find a unit price, class, we need to divide the cost by the number of units. What's the cost, class? $19.89. If it's money, that's cost. Does that make sense? Cost is how much money you pay, divided by the number of units. Well, how many units are in a 51-ounce bottle?
51 ounces.
51 units, right? 51 units, each unit being an ounce. So we divide. What goes inside the house, class?
The 19.
1989, the top number, $19.89. What goes outside the house, class?
51.
51. Let's see, how many times would 5 go into 19?
3, 5,
5 times 5 would be 25. That would go into 19. 3 times, right? 3 times 1, class? 3 times 5.
15,
Let's see, there's going to be a whole lot left over when we subtract.
5,
5 and 4. That's still smaller than 51, but it's pretty close. Let's bring it down to 9. How many times would 5 go into 45?
9,
9 times. 9 times 1, of course.
9,
And 9 times 5?
45.
Hey, that came out evenly. So, the unit price for the 51-ounce bottle, class, is 39 cents per ounce. How much did it cost for the 17-ounce bottle?
About
44 cents an ounce. So which one's the better deal?
39.
The 51-ounce bottle. It's cheaper per ounce. Now, its price is higher. Like if you're looking at the price sticker, you're like, man, that's a lot more expensive. It is, but you're getting so much more product, it's actually cheaper overall. Now, what if you don't use the olive oil? Or what if you have a small pantry and it takes up a lot of space? Now, there's those things to consider as well. But just looking at the numbers, it's cheaper to get the 51-ounce bottle than the 17-ounce bottle. Usually, by the way, how many of you have heard your parents say usually bigger sizes are cheaper? Is that always true? No, not always, but usually. Usually that's the case. Flip over, if you would, to page 58. Let's take a look at some word problems together. Look at number 12 and read that for us, if you would, Corey.
Find the unit price to the nearest set of a 15.75 ounce size bag of potato chips priced at $3.75.
All right, when I go to find unit price, class, I need to divide the cost by the... It's still on the chalkboard. You can read it. Class, how do I find unit price? This means divided by. So let's try that again. In unison. Class, how do I find unit price?
Cost divided by the number of units.
All right, Corey, what was the cost of the potato chips?
$3.75.
And what was the number of units, Corey?
15.75 ounces.
All right, so when we go to set up our division problem, class, what goes into house? $3.75. What goes outside the house, class?
17.75.
Are we allowed to divide by decimals, class?
No.
So what do I have to do, Corey?
Put the decimal over twice, 2 times.
So it's over here now, right?
And then you gotta do the same thing in the divisor.
All right, so now it's over here. When I move it over, also move it up top, and I'm going to add a few zeros here as well. At your seats, do the division. At your seats, see what is the unit price for these potato chips. How much are we paying per ounce? Now remember, we don't have to divide till it comes out evenly. We just have to divide out enough digits so we can round to the nearest cent. So I get the 0.2, then my next digit's a 3. The next digit I tried a 7 and it wasn't big enough, it needed to go to an 8, but it doesn't matter. Regardless, if it's a 7 or an 8 class, what's that going to do to the 3?
Bump it up.
Bump it up. So what's the unit price approximately, class?
24 cents.
24 cents per ounce for the potato chips, for Oz. All right, questions on unit price? Basically, you're doing a lot of division, which is a bummer. Look at number 13. Read that, if you would, please, for us, Jalen.
A half gallon of milk is priced at $2.20, and a gallon of milk is priced at $3.68. Which size is the better buy?
All right, in other words, which is better value? Well, one thing we could do, class, is we could find the unit price for the half gallon. And then we could find the unit price for the gallon. But I'm lazy. You know what a better way to do would be? How many half gallons does it take to make a gallon?
2.
2 of them. How much is a half gallon, class?
0.5.
No. How much?
Oh.
Looking at the problem, how much does it cost for a half a gallon of milk?
$2.20.
$2.20. So Ben, what if you bought 2 half gallons? How much money would that cost?
$4.40.
$4.40. Is that better than just buying a gallon?
No.
No. So which is the better buy? The gallon of milk, right? We didn't have to do any work on paper at all. We lazy, right? So that's one way that we could do it here when it's that easy to just compare. Now, why would somebody buy 2 half gallons instead of a whole gallon? For instance, my family, that's what we do. We buy the half gallons. Why? What do you think, Sam? Yep, if you open the gallon, and our family doesn't drink a lot of milk. You know, think with 4 kids we would, but they don't drink a whole lot of milk. They don't care for it too much. They get their dairy other ways, but so what we do is we just use the half gallon. So that way, once you open it, it starts going bad, right? You usually have, what, a week at most with a gallon of milk? And how many have ever had bad milk in your fridge? You open it up, you can smell it. Sometimes you can see the stuff floating at the top. All right, anyway, anyone ever not noticed until you drank it and had to taste that? Isn't it awful? Anyway, all right, number 14. Number 14, go ahead and read that for us if you would. Paige.
The purity of gold is measured in carats. 24 karat gold is pure gold. Most gold jewelry is 14K gold. Find what fractional part in decimal 14K gold is a pure gold. Find the decimal to the nearest thousand.
All right, so when you buy gold jewelry, why wouldn't they make jewelry 24 karat gold? I mean, if it's the purest gold, wouldn't you want like pure gold jewelry, Elaine?
It's like really expensive.
It would be really expensive. That's not why.
Because they don't want to spend money.
No, that's not why.
Is it expensive to make?
It's not even that expensive to make.
It's rare to find.
It's soft. Gold is a soft metal. So if this ring were, if I can get it off, we'll just leave it on. If this ring were 24 karat gold, it would bend every time I squeezed on it. And that's no good, right? So they mix the gold with harder materials as well, which makes the ring actually hold its shape better. So most jewelry is 14 karat gold. But pure jewelry is what karat, class?
24 karat
What
gold.
fractional part would that be? What do I need to do here, Paige?
24 over 14.
Ooh, other way around.
14 over 20.
Yeah, take the part to the whole. Remember, that's what fraction means. Relate the part to the whole. 14 carats to 24 carats. Of course, we can reduce that down to get.
7 over 12.
So that's the first answer. What fractional part of pure gold is 14 karat gold? But then it says it wants it as a decimal to the nearest thousandth. How do we turn a fraction into a decimal, class? Divide at your seats. Find the decimal. At your seats, find the decimal. And what do we get here, Jalen?
0.586 repeating.
Not 6 repeating. We should have gotten down to a 40 where 12 goes into 40 3 times. It ends up keep repeating with a 3 over and over again. So it should have had 0.583 repeating. Or since they said round, we could just say 0.58. Does another 3 round it up, class?
No.
No, so not 0.584, 0.583.
I mean,
Yeah, it's 0.583333333, right? So is another 3 going to bump this up?
No.
It's going to stay at 3, 0.583. Should have been our answer
I
here.
was writing 3 as I was looking at the 6. That's why I wrote 6.
Okay, all right. Number 15, read that for us if you would. Bryson.
Okay, Noah plays basketball for Grace Christian School. Last season.
I love that. Go us. I didn't know we had a baseball team. Well, I mean, we did years ago when I first came here. Anyway,
Last season he had 19 hit out of 40 at bats. What was his batting average?
that's an amazing batting average, by the way. How do you think your batting average? Well, you take the number of hits divided by the number of at-bats. That's times you actually come up to the plate and get to swing, okay? So, how many hits, class? How many at-bats?
40.
Let's find his batting average. It's going to be a decimal to the nearest thousandth. At your seats, find his batting average. A decimal to the nearest thousandth. If you wanted to keep track of your own batting average during this year in PE, you could. I'm not going to keep track of it because I can't keep track of all your at-bats, but you can. Right? How many times you come up to bat versus how many times you get a hit. And we get 0.475. 0.47, that's an amazing batting average for baseball. That is really good. All right, way to go, Noah. You'll have to tell him if you see him in the hallway sometime. All right, questions on that problem? All right, look across the page. Let's talk a little bit about ratios. Did you learn about this in 6th grade? We learned about ratios in 6th grade. Some of you are nodding that you have. Note this, a ratio is a comparison of two numbers. Write the word comparison at the top of the page. Top of page 59, where it says ratios. A ratio is a comparison of two values. A ratio is a comparison of two values. For instance, just a moment ago, we compared price to the number of units. That's a ratio. We compared hits to the number of at-bats. That's a ratio. We could compare A's that you've made to the number of quizzes. Maybe we say that we've taken, oh goodness, I think it's 5 quizzes so far, and maybe Griffin has made A's on 3 of his 5 quizzes. We would have a ratio of 3 to 5. Now, we could write it a few different ways. We could write it with words 3 to 5. We could write that. We could also write it with a colon, and it still read 3 to 5. Look up this way. Or we could write it as a fraction and still say 3 to 5. Which way is the easiest way to write it? This way is the easiest way to write it. Since mathematicians are lazy, typically we'll write ratios as fractions. However, in a ratio, we don't refer to it as numerator denominator because if we write it this way, like that's not a numerator and a denominator. Does that make sense? Note this term. You see it there in bold. The first number in the ratio is called the antecedent. The first number in the ratio is the antecedent. Now, this is a term I think you've heard in language class last year, right? Antecedent. Remember we talked about pronouns? If I say, you know what I heard about Ben? Well, he blah, 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 and this happened to him, and his blah, 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 and then he blah, blah, blah. Who are all the his, the he, and the hims talking about, class? Ben. Because I mentioned his name first, that told you that all the times they said he, him, or his are talking about Ben. Ben was the antecedent. Do you remember learning that in language? The word that the pronouns are talking about. It's the antecedent. Now, my little sister, I'm going to get myself in trouble if she sees this video. I don't think she's subscribed to my channel, though. But my little sister used to have this bad problem in junior high and high school. She'd be telling us a story in the car, we'd be going wherever, and my little sister would start with, she blah, 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 and then she blah, blah, blah. And my dad would get so frustrated, like, stop, Michelle, who is she? Oh, so-and-so. Please start with that next time. Like, my dad got really bugged by that. He's like, I don't even know who you're talking about. Whoa, who is she? Who is he? Right? Got to have the antecedent first. The antecedent always has to be given first before you use pronouns. Antecedent is the first term in the ratio. The second term is called the consequent. Now, when you hear the word consequent, what does it sound painfully like, class? Consequences, right? And you all have good parents who have trained you well, and part of training and disciplining is consequences, right? You do this and something bad befalls you, whether it's a lost allowance, whether it's being grounded, whether it's loss of privilege, or whether it is the good biblical method of discipline, right? Okay, you know what I'm talking about. Some families call it a whooping, all right? Whatever, right? Discipline. But here's the key, right? Normally, normal households, it's not like Ben comes home and his mom's like, Ben, bam, 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 bam. What'd I do? I don't know, but I know you're going to do something. Most households don't work that way. We would call that a dysfunctional home. Most of the time, you do something bad, and after you've done something bad, then you get consequences, right? You do it bad, and you hope you don't, but be sure your sin will find you out, right? So you do something bad, then consequences come. You smart off to mama, and consequences usually come real quickly. How many can attest? Yes, that happens real quick. Okay. But it comes after still, right? Even if it comes quickly, it still comes after. The consequent comes after the antecedent. Does that help to remember it? So the first term, class, in a ratio is called the antecedent. The second term is called the consequent. The first term is the antecedent. The next term is the consequent. Very good. And so we got 3 different ways to write it. 3 to 5, 3 to 5, 3 to 5. We could compare boys to girls in this classroom. We've got 6 boys in the classroom to 5 girls. So the ratio of boys to girls is 6 to 5. What if I wanted the ratio of girls to boys?
5 to 6.
5 to 6. Right? Just depends on what you're talking about. If it's boys to girls, 6 to 5 is girls to boys, 5 to 6. What if it were the number of girls to total students? Well, how many girls, class?
5 to 11.
5. How many total students?
11.
11. So we'd say 5 to 11 is the ratio of girls to total students in the classroom. Does that make sense? Okay, so we can compare really whatever we want to. We just put the first number there. Now, here's the key though, and write this down, always reduce. We always reduce ratios. Regardless of how they're written, whether they're written in fraction form, with the word to, with the colon, doesn't matter. We always reduce ratios. So for instance, if we had the ratio 14 to 2, as you see in that first sample box, let's say there were, let's say one team in softball scores 14 runs and the other team scores 2. That'd be a really bad day at PE. I'd be very bored by that. I don't want games that are 14 to 2. But anyway, if that were the score, we would say the ratio is 14 to 2, but we would reduce it, right? We would divide a 2 out. Now watch. We wouldn't say 7. A fraction, we can say 7, but a ratio is what, class? What's the word I told you to write at the top of the page? Comparison. In order to compare something, you have to have 2 things. So when you reduce a ratio, you can never get a whole number because now you have nothing to compare. Even if it's a ratio, when we reduce it, we would reduce to 7 to 1. Does that make sense? You have to leave that 1, otherwise you don't have a comparison anymore. That's a little bit of a subtle difference between ratios versus just a straight fraction. It has here, if you look above the next shaded box, it talks about a ratio of tables to chairs. Let's suppose there were 4 tables and there were 10 chairs. What's the ratio of tables to chairs? 4 tables, 10 chairs. What's the ratio of tables to chairs, class?
4 to 10.
4 to 10. But we would reduce that, class, and we would say
2 to 5.
2 to 5. Now, important to note, be careful with the order. What if it said, class, what's the ratio of chairs to tables? It's 5 to 2. If they said, what's the ratio of chairs to tables? Does that make sense? So the order is going to matter as we look at these tomorrow. Look at the example at the bottom of page 59, and then we'll wrap it up here. Actually, I think we'll wrap it up here anyway. We'll stop there. All right. For homework this evening. For homework this evening, I'm going to have you tackle this. Even though we didn't get very far with ratios, I think they're fairly straightforward. So I'm going to have you still do the assignment, even though we didn't get as far as I wanted to get. And we'll practice more with ratios tomorrow. But give them a shot tonight, see how you do. Page 61, in the homework section, do 1 through 13. Page 61, homework section, do 1 through 13. And on page 64, we're going to pick up where we left off last night, just doing 53 to 59. So a little bit shorter section on the back end there. 64, Do numbers 53 to 59. One more time. Page 61. Homework 1 to 13. Page 64. 53 to 59. We'll resume ratios in our next lesson. Have a wonderful rest of your day.